Hope you have enjoyed the previous chapter, Chapter 1, which covered the JSON fundamentals, variant data type, how to load JSON data using worksheet via insert statement, parse JSON UDF, and query JSON element using the colon and dot notations. This chapter, Chapter 2, will focus on loading data into Snowflake tables from S3 Bucket. We will quickly start with S3 configuration, S3 integration, JSON file format, and data loading using copy command, and how to validate the loaded data and errors which can occur in this process. I will demonstrate the copy command using a free S3 bucket provided by AWS, so you can practice them while watching this video. Welcome back to my channel Data Engineering Simplified, and to this Handling JSON Data in Snowflake playlist for true data professionals like you. This is a complete playlist to cover JSON handling in Snowflake. Link for all the chapters can be found in the description section below, or click above in the information icon. So let's start with Chapter 2. Before we deep dive, let's discuss about the flow which we are going to practice. S3 is a simple storage service, or commonly called storage object or S3 bucket, provided by AWS, and any kind of file can be stored in this object storage. Either you should have a free or a paid AWS account to create S3 bucket, or your organization has created an S3 bucket where you can place the file. Each S3 bucket has a unique name across all the AWS accounts, and that name will be used to establish a link between AWS and Snowflake services. When an S3 bucket is created, by default, this bucket is set as a private and nobody can access it publicly. So you have to make the bucket public and then define a policy so Snowflake as a consumer can connect to this bucket, list the bucket, and read the file stored in this bucket. Absence of correct policy definition, Snowflake cannot list and or read the file before it can perform the data loading operations. So we will create an S3 bucket, we will make the bucket public, we will add the policy, then we will create an external stage using SQL statement and then list the file. It is not necessary that your Snowflake instance should be running on AWS. Your Snowflake instance can run on Azure or GCP, and it can still establish a connection with any S3 bucket if you have done a proper configuration and define a proper policy to establish a connection to give access to the Snowflake instance. Please refer the description section where I have provided the free S3 bucket which you can use for this video. So let's jump into our Snowsite web UI. So I am in my Snowsite web UI, and I am going to create a stage which will establish a connection with S3 bucket. To do that, I will click on this schema, click on this create button, go to this stage option, select Amazon S3. It brings a new worksheet, and this worksheet is automatically populating the create stage SQL command. On the line number 2, it is expecting a URL, which is nothing but a URL to your S3 bucket. And before we really create this external stage, I am switching to my AWS account, where I will demonstrate quickly how we can create a simple S3 bucket, make it public, and define the policy JSON file, which will help us to integrate this external stage with S3 bucket. I am not going to use any AWS secret key and AWS key ID. However, in your enterprise environment, you may have to use credentials, which includes your AWS secret key and AWS key ID, which is out of the scope of this video. So here I am in my AWS console, and on your home page, you can see that S3. I click on this S3. It takes me to the page where I can create an S3 bucket. I click on this create bucket button. It opens a new page where I can specify my bucket name. If you see, the bucket name must be globally unique and must not contain spaces and uppercase letter. I can also choose different region from United States and many other places. So I'm not going to do anything here. I will simply give the name of the bucket and create the bucket. It says my S3 demo bucket. Right now, I am not making any changes anywhere and simply clicking on create bucket. It says the bucket already exists. Just to differentiate, I added one extra T. Now I got a successful message that my S3 demo bucket is created. I click on this bucket. It takes me to the page. I can click on the permissions option. If you look into this option, it says block public access, which is right now on. I click on this edit button and uncheck this block all public access checkbox and save changes. It expects me to confirm this operation. Now changes are applied. Now once I have made my bucket accessible publicly, I have to define the bucket policy. Without that, it will not work. So I can click on this edit button. Here you can also click something called policy generator. In the policy generator, it opens a new page where you can say, okay, I would like to define S3 bucket. I will specify star. What does it mean? That everybody, this S3 bucket will be accessible to everybody. And if I want to give all kind of access to this S3 bucket, I can say all actions and I can give this ARN number. This is my ARN number. Click on the copy. I put this ARN number here and I say click add statement here and say generate policy. So this is how the policy is generated, which I can copy and I can paste it. When I scroll down, it says there are total 13 lines, no error, no warning, and no suggestion. Good. And I click on the save changes. In your enterprise environment, this effect and action may look little different. Right now, for a simplicity, I have just given a public access and all kind of operations can be performed in this bucket. Now here it is clearly saying that this bucket is publicly accessible and this is the policy looks like. Now we are going to go to the Snow site, create an external stage and see if we can access this my S3 demo bucket from Snowflake or not. So if you look into the line number 7, I am going to create a stage called my S3 stage and the URL indicate that I am going to establish a connection with my S3 demo bucket. Let me execute this SQL statement. So my S3 stage got created successfully. Now let me describe this stage. I got the result. And here it says that my URL is s3:/my S3 demo bucket. Good. Now to list my stage, I have to run list SQL statement and I have to use character to list external stages. I do not have any files available in my stage environment. Let's go back to our S3 and try to put one JSON file. I am back on my S3 demo bucket and I click on a create folder. Going inside the folder and I am uploading some sample files. So these are the 4 JSON files which I have used in my previous chapter. I'm going to add them. It took a while. All of them got added into the system. Let me run this list command. I have all the 4 files got added. So this is how you can integrate with your Snowflake with external stage where S3 is source of my data. For rest of the video, I'm not going to use this bucket. This bucket will not be accessible to you. I'm going to use an S3 bucket which is freely available and provided by AWS. So let's start with those sample files. So here is the S3 bucket provided by AWS and can be accessed without any credential. It has few sample JSON files which we are going to ingest and try it out throughout this video. Now I'm going to create an external stage and this is how the SQL syntax looks like. This URL is pointing to the S3 location which is provided by AWS. So let's create this external stage. It is created successfully. Now first describe this external stage. So it has taken all the default value. And if I look into the stage location, it is pointing to this AWS sample S3 location. Good. Let's run the list command. So here we have a total 6 sample files, and all the data files are related to US legislator. So area, country, events, membership, organization, and person. Now the question we have in our mind that how we can really see this data before we load this data into a table. For that, we are going to create a file format called JSON File Format, and the type value will take JSON. Compression is auto, and I am not giving any other parameters for this video. So let's create this file format. So my file format is created successfully. Let's describe the file format. It has taken all the default values. If you make any changes to any properties, you can see what is the default value and what is the specified value given for this file format. So if you look into the type property where the type is JSON, however, the default value is CSV. You can refer this video to understand how you can run a query on external table. This is how the syntax looks like. So I am specifying my external stage followed by the name of the JSON file. Since this external stage is already pointing to this location, I am going to specify the relative position of this JSON file, right? And then I'm passing the file format name, which is our JSON file format. And when I run this select statement, it will fetch all the data set which exist in this area.json file. So it took some time to process the data because this data is available in the external stage. So this is how this JSON looks like. I can copy the JSON and I can go to my editor. So when I copy this data set, this is how my JSON looks like. So there is no root element and it has only 3 elements: ID, name, and type. Good. For our example, this looks good. And if I see, I have total 554 record and each of the field is a variant type. We have seen in our previous video how you can use the colon and dot notation to query data, and this is how it looks like. So you can pause the video and see how the structure looks like. So the T is the alias which I have specified, which you can give any other name. And this $1 is a first field because in the JSON file we have only one field. That's why to access the first field, we have to use $1 notation. And once you get the $1 notation, which represents your first field in your JSON file, then you can use the colon notation to access individual element. And how do I know what is the individual element? Then I can go to this editor and understand, okay, ID, name, and type are the different element within the JSON object. If you're not sure how this works, I would request you to watch chapter 1, which covers this concept in detail. Now let me run this statement. So state ID, state name, and state type, exactly 544 record. Good. Now we are creating a table called area JSON and which takes variant data type. So my table is created. And now I'm going to run the copy command, and this copy command will again refer the area.json file, explicit file name, and it is passing the file format JSON_file_format. If you look into the syntax here versus syntax here, they are slightly different. So make sure that you use appropriate syntax and the grammar which is given by Snowflake. Now let's run the copy command. So the data is loaded successfully. I have no issues loading the data, perfectly fine. Now let's run the select statement. Now this is giving exactly the same result, and this time the query performance is far better compared to accessing the external stage. Okay. Now this is another select statement which I am firing on the area.json table, and this is the name of the column followed by colon sign followed by the JSON element, and then I'm typecasting it, and then I'm giving alias. So this is how my result looks like. So now I managed to access the JSON object from my external stage, run the copy command, got the data inside the area.json table, and I can access my JSON data through the colon notation. Now I'm going to create another table called area standard table. And this time, instead of running a copy command from the stage location, I am using the select statement, and this select statement is accessing data from the external stage, and let's see how does it work. So you can pause the video and try to understand how the syntax looks like. It is pretty standard, and I have already covered this in detail in another chapter. So it took 1.3 seconds to load the data. The data is also loaded without any issue. It looks perfectly fine. Now, there is a third approach which you can also follow. If you want to create a table using the select statement, then you can write create table as select statement. And let's try that out. I have given the name of the table called area underscore using underscore insert. This took 1.5 seconds, not a big difference. However, I do not recommend this approach, and I'm going to tell the reason why I do not recommend this approach. So I'm clicking on the database link from the left panel, clicking on this database, clicking on this schema, going to the tables. I have area underscore JSON, area underscore standard, area underscore using insert. So we created 3 tables to populate the same data. First, I click on this area underscore JSON, and it contains 554 rows. Total size is 159 KB. Good. This is how the data looks like. And if I look into the copy history, I can see the data via copy history. If you hover on this location, it is clearly telling that this data was loaded from this location and name of the file was area.json. If I go to the next table, which is area underscore std, it takes only 7.5 KB of data, and the data is already in the tabular format. And if I look into the copy history, it also shows the same detail. So the data is copied from here, and it was copied from the area.json file. Looks good. When I go to the area underscore using underscore insert, I can also see the data. Looks good. It also takes the same amount of data set because area underscore standard and area underscore using underscore insert having the tabular format of the data set. But when I go to the copy history, I do not have any copy history. Running a copy command gives better traceability, and if there are any error which you want to track it later, copy command is a better rather than insert operation. Okay. Let's quickly see how the copy command looks in your query history. So this is the first copy command which insert the data directly into area underscore JSON table. Let's open this. So the first step is external scan followed by insert statement, and the result is shown on the screen. Looks good. And this is another copy statement which is actually running a select statement on the top of external stage. Let's open this, and it is the same. So the first step is external scan followed by insert statement, and the result is shown on the screen. Okay, so no specific difference. So you can directly copy the data into a table from external stage, or you can run a select statement on the external stage and then copy the data into a tabular format. So this is how you can use the dollar notation and access the external JSON file, understand the structure, and then you run the copy command, copy the data, and get the data stored in your table, either via variant data type. And if your JSON structure is very well defined and not changing, you can also use the copy command along with the select statement on the top of external dataset. Next, we are going to see slightly complex JSON object and see how this copy command works there. So this is my new worksheet where I'm trying to insert the person JSON data. So first I am going to list the external stage. So this is a person.json file which has quite a lot of data set available. And if you look into the overall path, I will only specify persons.json because this part is already part of my external stage mapping. So what happens if I try to do select star from a file which does not exist? Let's run this. You will not get any result because person.json doesn't exist. Actually, the name of the file is persons.json. Okay. So let's run this select statement. So I can see it has 21961 rows. Good. And let's click any one of them. Let me copy this data. So I have copied the data in my JSON editor, and this is how the content looks like. It is a valid JSON. Okay. So this JSON does not have any root element. It has a lot of element. For example, birth date, family name, gender, given name, ID, image, name, and sort name. And then it has a lot of sub element, which is nothing but an array object. And it has a lot of child element, which is array object. So using this tool, you can analyze your JSON first, and then you can define what kind of select query you would like to write. Going back to my worksheet. So I'm just creating a table called person_JSON. and I'm running this copy command, which will insert data into the table. Looks good. The data is loaded without any issue. Again, if you do not know how to handle the error while loading the data, I request you to watch my data loading playlist. The link is given in the information icon. Let's execute the select statement. So my data is loaded properly in the JSON underscore person data. Looks good. Same process. Now I'm going to execute a select statement to parse the JSON, and this is how it looks like. So since my column name is JSON underscore data, I am using the colon character notation to fetch the different element. Then I'm doing a typecasting and then using the alias. So here it is ID, given name, family name, name, birthplace, and I'm using the case statement, getting the result as a M or F for male and female respectively. And if the gender is unknown, it is actually giving U. Then I have an image, and then I have a contact detail, which is an array type, and I would like to understand what is the length of this array. And then I'm using fax, phone, and Twitter ID. Okay. Now let's run this statement. So using the colon notation, I'm able to extract each of this information as per my requirement. However, when I see the length of this array, which varies, sometime it is empty and sometime it has like 3, 2, and it varies in number. So it looks like 3 is a max, and then wherever it is 3, I can fetch the detail appropriately. However, where it is less than 3, I have an issue because this Twitter ID is coming in the phone. Okay, and let's try to understand this data set. So if you look into this individual JSON data set, it has 3 different contact detail: fax, phone, and Twitter. That's why this user has got fax, phone, and Twitter ID properly. However, this particular JSON does not have the contact detail. That's why it is null. And in this case, if I copy this has phone and Twitter. So if I try to access index 0 and index 1, it will give me the incorrect result. So now my future chapter will explain how exactly you can solve this problem and how you can dynamically populate or ingest your data, making sure that you are not corrupting your data set. And that's why it is important to ingest your data into a variant column first. And once it is ingested, you can write your transformation rules before final table gets populated. This chapter has covered the data loading using S3 Bucket. However, there are many scenarios we have not covered, as many developers don't have access to S3 Bucket, or they do not understand how to set up S3 Bucket with proper policies correctly. And we used a free S3 location provided by AWS, so we all can practice and understand how the data loading works with S3. In the next chapter, chapter 3, we will use internal stages, which has very similar behavior, and we will explore many more interesting cases and understand data loading challenges with JSON data files. JSON data is everywhere, be it IoT device data use case or clickstream data use cases like Google Analytics or Adobe Analytics, SaaS API use cases like ServiceNow or Salesforce, social media data like LinkedIn, Facebook, Twitter, YouTube, or Instagram. They all produce data in humongous scale, and only format through which these datasets can be consumed is JSON. We have only scratched the surface of JSON, and this is only the tip of the iceberg. There is a lot more to learn about JSON and Snowflake, and all future chapters will cover it in this playlist. And what all we are going to cover: for example, loading JSON data at scale, processing them at scale, use write functions to transform and flatten JSON objects, processing new line and different kind of JSON files, copy command and delta load pattern with JSON in Snowflake, deduplication and other parameter in the file format, best practices and the limitation of variant data type with respect to JSON. The list is big. So if you want to master the JSON processing in Snowflake, watch the entire playlist. Continue to watch this space and also explore my other playlist, which covers wide variety of topics in Snowflake. Thank you for watching. Keep learning and keep growing.